Hello and welcome to Cambridge O-Level Physics paper number 1, multiple choice. This is October-November 2020 paper. The code for this subject is 5054 and this is version 2 of the October-November 2020 exam series. So let's start. The first question, it says, a heavy nail is fixed firmly to a wall. It is pulled by a string at 40 degrees to the vertical. The nail does not move. The three forces act on the nail. Number one, it is weight. Number two, the tension on the string. Number three, the force are exerted by the wall. Which diagram drawn to the scale represents these forces? So in this diagram, the only pull or the tension on the string is shown to us. Remember, the weight of the string will act downwards, and the overall reaction or the force exerted by the wall will be the sum of this tension and the weight. So applying the parallelogram law, so I can always draw my weight as something like this. So this will be my weight. So my overall, the resultant R vector or force vector will be something like this. So vectors. So with the help of parallelograms or this whole thing, the overall uh, diagram or the scale of the diagram will look something like this. So which diagram basically shows amongst them shows the best representation? So we can see that the tension's here, weight is downward, and the reaction or the force R or reaction force exerted by the wall is this. So tension, weight is downwards, yes, reaction R, this looks good. Tension this direction, no. Weight downwards, R, no. Tension this direction, weight is this, R is in this direction, no. Again, tension is different. So best answer is answer number A. Next question. It says a car begins to move. It speeds up until it reaches a constant speed. It continues to travel at this constant speed for the rest of the journey. So what happens to the acceleration and what happens to the velocity of the car during the journey? First of all, remember when a car begins to move, it basically accelerates. So as it accelerates, the velocity changes and till it reaches a speed and then moves at a constant speed. So till the point it reaches a constant speed, the acceleration and the velocity are constantly changing. So we can see from here that both acceleration and velocity changes. So let's see which is the best suited answer. So part A, both acceleration and velocity change. So yes, it is right. Part B, only acceleration changes. No, this is partially correct. Part C, only velocity changes. Again, this is partially correct. Neither acceleration nor velocity changes. So this is wrong. So answer number A is the best suited answer. Next question. Question number 3, it states that the speed time graph for a car's journey is shown. During which part of the journey is the car moving with a non-uniform acceleration? So remember, this is a speed time graph and acceleration is the slope of the speed time or the velocity time graph. Okay, so we have to see where the slope is non-uniform. For this selection point, we have a constant value of slope, and remember, slope is always calculated as change in y-axis. So this is our y-axis. This is our x-axis. So during B part, it remains same, and during this region, basically the slope is not uniform. This, if we measure the slope at this point, it is different. If we measure the slope at this point, it will be different. So at these 2 points, so we can easily say that, and so this point C can be an answer. Then at in the region D, if we measure the slope on any of these 3 points A, B, C, we'll find out that the slope will have a same value. So Uh, the only region where we have a non-uniform slope is C. So the answer of this part will be C. Next question, question 4. It says a car is traveling forward at high speed. The brakes are applied and the car skids along the road surface. Okay, in which direction? Says in which direction and where does the friction force act? So, say for example, this is our car. Pardon my drawing. So this is our car, and we have applied the brakes, and this is moving in this direction. So when the brakes are applied, so the overall friction force will be acting backwards. So friction force will be acting in this direction, uh, and it will be acting on the tires of the car. So the friction force will be acting backwards and on the tire, yes. Forward on the tires, no. Upwards on the tires, no. Downwards or on the road, no. So friction force acts backwards. So part A will be the best choice. Next question. It says a car of mass 800 kg has a forward acceleration of 2.5 meters per second square. A frictional force of 1200 Newton opposes the motion of the car. What is the driving force due to the engine of the car? So let's solve this. So for example, this is, let's say, our car. Again, pardon my drawing. This is moving on a road. So this, we have a person sitting here. So it is moving with an acceleration A 2.5 meters per second square. The mass of the car is 800 kg and the frictional force acting, F friction acting, is 1200 newtons. So the forward acting force is 8 mass into acceleration, that is 2.5 into 800, and that gives us 1600, and so 2000 newtons. So the forward acting force is 2000 newtons. And what is the driving force? So basically when the engine is driving the car, this is the force that is producing or the forward acceleration, and basically engine is also overcoming the friction of the car. So the total force, F total, will be F friction plus forward acting force. That is the force that is produced by the engine in order to overcome the or in order to drive the car with this particular acceleration. So this will be 3200 Newton. So the answer is D. Remember, a common mistake people make in this question is just simply subtract 1200 friction from the forward acceleration force and they get around 800 Newton and they select answer number A. So this is not the right approach to do it. So engine is basically, when a car is driving forward, our engine is basically overcoming the friction force and is providing the desired acceleration, which is as per required by the driver or whatever we are or whosoever is the person that is driving the car. So the best answer is answer D, 3200 Newton. Next part, next question. It says a satellite orbits a planet in a circular path as shown. It has constant speed. There is a force on the planet due to the satellite. In which direction is the force on the planet? So the satellite is orbiting around this planet, and the centripetal force will be in this direction, and the force on the planet due to the satellite, that is basically in the opposite or in the B direction. So that is answer number B. This is the direction in which the force on the planet due to the satellite. So next part. It says a block is hung on a spring balance. The marker inside the balance is pulled down by the block. What can the position of the marker be used to determine? So this is a spring balance. Remember, spring balance is used to measure the mass of an object. So let's see. So mass of an object can be used to measure mass of the object, and also it can be used to measure the weight of the object. And remember, for mass, the units will be grams or kilograms, and similarly for weight, the unit shall be Newton. Okay, so what would be the best answer? The mass of the block in kg? Yes, it can measure that. The mass of the block in newtons. So newtons are not the units for mass. So no. Moment caused by the block? No, it doesn't measure the moments. Weight of the block in kg? Again, weight of the block is in newtons. So the best answer is part A. Next question. Question number 8, it says there is an astronaut on the planet which has a gravitational field strength 1/5 of the value of Earth. He hangs samples of the rock from the spring balance designed for the use on Earth. So remember this, designed for the use. Each sample has a mass of 0.1 kg. The spring balance reads this. So this is basically reading on the planet. How many samples of rock are there? So let's try to solve it. So the gravitational field on Earth is 10 meters or per second square. So field strength. So the gravitational field or acceleration due to gravity on the planet will be, say, 10 divided by 5, 2 meters per second square. So we can say that on Earth, 0.1 kg is corresponds to 10 meters per second square. This is one way. Then a similar block, if taken on an acceleration due to gravity that is 2 meters per second square, what will be the value of or the mass of the block on the planet? So it will be, there will means that definitely there will be weightlessness. So it divides by this. So mass of block on planet. So this is planet. This is Earth. So a 1.1 kg block will be 0.1 divided by 5 kg on the planet. That is because of the decrease in the gravitational field strength, and that basically causes the weightlessness. Then it says, so the our reading is 1 kg, one block. This again, everything is happening on planet. So one block on planet is 0.1 divided by 5 kg. This is one block. So how many blocks? How many blocks? Just simply divide 1 kg divide by 0.1 multiply by 5 or 1. This is what we have to do. So the total number of blocks, 5 divided by 0.1 equals to 50. So the best answer is D. Next question. Question number 9. It says an electrically charged plastic ball is at rest. Which types of field are caused by the ball? So remember, uh, electrically charged plastic ball. So say for example, this is the ball and this is lying at rest. So for example, this is negatively charged. So the field caused by this charged particle will be electric field, E field. And this charge has some weight, and that will be, having some sort of bending the, gravitation or the fabric of space-time. So you can call it as there is an extremely weak gravitational field associated with it. Yes. And this, remember, this is a single charge particles, electrically charged particles. So this is a charged particle and it is static. Remember, it is not moving. So static charges do not create magnetic field. Only moving charges or the dynamic charges causes magnetic field. So we will only have an electric field and gravitational field. These are the two fields we'll have. So the best answer is electric field, gravitational field, part B. Next question. Question 10. Which list contains quantities that can be changed by a force? Okay. Mass. So remember, mass of any object remains constant. Shape, yes, we can shape, we can change velocity, but we can't change mass. So mass can't be changed. Again, part B, we have mass, so again, we can't change this. Again, part C, we have mass, we can't change this. So part D, we can change the shape, we can change the velocity, and we can easily change the volume. So part D will be the best option. Next question, question number 11. It says, an extension load graph is plotted for a spring. Which point marks the limit of proportionality for this spring? So, uh, so for a spring extension, generally spring is given as F equals to X. So for extension in the spring, say X, and the load on the spring is given as F, and the relationship for this, or we can say X equals to 1 by K times F, something like this. So this is the graph we have, and this is the proportionality limit. So uh, the point till the line remains linear is the point till where the proportionality limit is uh, is you can say achieved, or is the you can say or you can say that the proportionality limit for this spring is sorry, I'm just missing a word for it. um, So here we have to find which point marks the limit of proportionality of the point. So if we see this line moves, or if we are going to extrapolate this line some way, so as it moves away from B, and approximately at this point, it comes out of, or it disobeys the limit of proportionality, because this is a linear relationship. So this line does not remains linear after this point. So till the point or marks the limit of proportionality, the limit of proportionality will be this point B, because after that the trend in the graph starts to change. So this is the boundary, or you can say the point at till which the limit of proportionality for the spring has been achieved. So next question. Question number 12, it says, diagram shows a diver uh, 20 meters below the surface of the lake. The total pressure at this depth is 3 into 10 to power 5 pascals. So P1, I call it 3 into 10 to power 5 pascals. And the depth is, say this is 20 meters. So the air bubble has a volume of 0.6 centimeter cube as it leaves the diver. So V1 is 0.60 centimeter cube as it leaves. It rises to the surface of the lake. So surface of the lake, this is the surface of the lake, where the pressure is this. So this pressure on the surface, P surface, is 1 into 10 to power 5 pascals. The temperature of the air in the bubble remains constant. What is the volume of the air bubble at surface? V surface we have to find. So remember, P1 V1 over T1 equals to P2 V2 over T2. Since temperature remains constant, we can ignore. So P1 V1 equals to P2 V2. So assuming P1, 3 into 10 to power 5.06 centimeter cube. Again, ideally it should be in meter cube, but we'll go with centimeter cube because the answers are in centimeter cube, so we're good. So P2, or the pressure on the surface, is 1 into 10 to power 5, and volume at surface is what we have to find. So using this formula, so we get this cancels out with this, 3 into 0.6, volume of the surface will be 1.8 centimeter cube. So answer will be C. So in this case. Next question. Question number 13. It says a ball is dropped from a height as shown. Ignoring the effects of air resistance, which statement about the total energy of the ball is correct? So remember, at this point, the ball have completely potential energy. At this point, the ball will have only kinetic energy just before falling, or negligible potential energy. And at this point, the ball will have both potential energy and kinetic energy. Overall, the law of conservation of energy states that in the absence of any external force, that is air resistance or anything that dissipates the energy, the overall energy remains constant. So it means that, so this whole potential energy, basically, for example, this is mgh and this is half mv squared from the formulas we have. So this is the height h, and this is falling under the gravity g. So this whole potential energy converts to kinetic energy, but overall energy remains same at all these points. So remember, at all these points, the overall energy is same. Greatest at point 1, no. Greatest at point 2, no. Greatest at point 3, no. So the best answer is A, because of the law of conservation of energy. Next question. Question 14, it says the student uses a force F to push a box a distance d across the horizontal table. The mass of the box is m and the gravitational field strength is g. How much work done by the student in pushing the box? How much work done by the student pushing the box? Calculated. So let's say this is our horizontal table, and we have a box of mass m, and the weight of the box is acting downward, and it's the force F is applied, and the box moves a distance d. So the box a distance d. So now, what is the overall or effective force that is there? So work done. So work done. Remember, work done is equal to force multiplied by the distance traveled in the direction of force. So this is the applied force, and this is the distance that is traveled across the direction of the force. So force is F, distance is d, so work done will be F into d. Next part. It says a workman rolls a barrel of 2000 newtons up the plank of length 2 meters onto a lorry. The back of the lorry is 0.8 meters above the horizontal surface of the road. What is the work done on the barrel against the gravity? So work done against the gravity, it will be the gain in potential energy. So whatever the energy that has been transferred while rolling the ball to this point is converted into the potential energy. So gain in potential energy will be mg into h. So overall weight, so mg is weight of the barrel multiplied by the height. So weight is 2000 newtons multiplied by height is 0.8. So this will be equal to 1600 joules. So the best answer is part B. Next question. Question is, what is power? Power is basically work done per unit time, or the unit for time is seconds. So power is work done per unit time, work done in joules, time in seconds. Okay, so best part is D. Next question. It says the diagram shows a glass tube filled with water suspended above a bench. The water is free to circulate around the tube. At point P, so this is point P, there is a convection current moving in a downwards direction, at which point is the tube heated to cause this convection current. So remember, this is a glass tube. So this is a glass tube. So if we are going to heat, so this is water. So remember, this is a glass tube and we are heating it at a certain point, and that basically generates the current. So remember, also I show this with an example. So for example, we have a beaker of water and we have a Bunsen burner, and that burner heats this beaker. So this basically generates a current in this fashion. So this is a way in which a current is generated inside the water, or a convection current that generates inside the water. So if I'm about to heat it at this point, it will generate a convection current in this fashion. So it will be moving up. So this will not be a case. Similarly, if I'm going to heat it from this portion, it will be again generating a current that will be going in this direction. That will, so if a heat is coming from here, again, this will be, say, how I can draw it. So here, so this is, so basically heat will flow from hotter to the colder end. So hotter end, this will be the hotter end, and this will be the colder end. So it will move here, it will move here. So overall, this sort of current will not be much of a possibility here. Similarly, if I'm going to heat it from here, after some time, when we will be heating, this portion will be heating up, so the water will be flowing this way, the water will be flowing this way, and eventually this water will heat up, and the overall volume is more in this direction, and overall volume will be less in this direction. So the thrust of the water, or heated water, will be from this direction to this direction, right? And similar situation can be applied from this side as well. So eventually, if we are going to see that if we are heating it from point A, what we are getting is that we will be heating more length in this direction, and we'll be heating less that length in this direction. So once the water attains a good heated, you can say, temperature, so the convection current will be from this direction to this direction, because we'll be having more hot water in this side compared to this side, and eventually the flow will be in this direction. So this will be the case actually in this, you can say, manner. So the best part for heating and generating this current, or this convection current in this beaker, will be this. So always consider the volume of water that is heated, once you reach this point. So that is on, you have to basically find out that this place would be the as much away from the source of heat as possible. So the next part will be question number 18. It says, which physical property cannot be used for the measurement of temperature? So length of a metal bar. So the answer is yes, the length of a metal bar can be used for, because metal expands on heating, and you can always measure temperature with that. Mass of plastic block. So the plastics do not have any specific behavior with respect to temperature, so we can't use plastics to measure temperature. Pressure of a gas, yes, we know that PV equals to nRT. That is a way in which we can measure temperature and a relationship between pressure of the gas and the temperature. Resistance of the wire, yes, rho equals R equals to rho length per unit area, and the rho, the resistivity, is a function of temperature. So yes, we can measure the temperature of a wire with the help of temperature. So eventually we can say that the mass of the plastic block cannot be used to measure the temperature. of any body. So next question, question number 19, it says a student performs an experiment to find out how much energy is needed to change the temperature of a steel by 1 degree centigrade. So amount of heat required to change temperature, delta theta, and heat that is required, capital C. So this is basically the heat capacity. So which is quantity the student is measuring. So the amount of heat, so that is C. So the heat capacity, part A. It is not latent heat because the state is not changing. It is not specific heat capacity because the mass of the steel is not constant, or not 1 kg or 1 gram or whatsoever there. Then again, specific latent heat, again, the state is not changing and the mass of the steel is not given in this manner. So this is basically the heat capacity which the student is measuring. Next question. A substance has a melting point of -17 and a boiling point of 117 degrees centigrade. In which state does the substance at -10 and minus at 100 degrees centigrade, 110 degrees centigrade? So the scale, let's say this is -17 degrees and this is 117 degrees. So this is the melting point and this is the boiling point. So before melting point, the substance is solid. After melting point, the substance is liquid. And after boiling point, the substance is in gas form. So currently we are at say -10. So -10 degrees is here, 110 degrees is somewhere here. So this is say our 0 degrees. So on the scale, we can see that we are in the liquid region. So at 10 degree, we are at liquid, at 110, we are in liquid. So answer number C will be the best choice we have. Next question. Question number 21. Which description of a liquid is correct? Liquid has a fixed shape? No, liquid does not have a fixed shape. Liquid takes the shape of the beaker in which, or the container in which it is poured. Fixed volume? No, again, yes. So basically liquid has a fixed volume. Yes. So this is right. This is no. Fixed shape? Again, no fixed volume. This is not correct. No fixed shape? Yes. Fixed volume? Yes. So this looks like a good answer. Then no fixed shape? Yes. No fixed volume? No. So the answer C is the best choice we get. Next question. Question 22. It says a mass of a gas is trapped inside a cylinder by moving piston. As the piston moves in, the volume of the gas decreases, but the temperature stays the same. What happens to the gas pressure and why? So remember this law, P1 V1 over T1 equals to P2 V2 over T2. So if temperature remains same, we just simply say that P1 V1 equals to P2 V2. So if the volume, and basically P1 V1 remains, or and this equals to constant. So if my volume is decreased, my pressure is increased. And that is because once I have compressed the gas, the molecular collisions increases with the piston and with the chambers of the or with the walls of this chamber, and that basically ends up more number of collisions per unit area, and that basically is the definition of pressure itself. So let's see, the pressure decreases, no, pressure decreases, no, unchanged, no, pressure increases, yes. So increases, the molecules collide more frequently with the piston, yes. So answer number C is the right answer. Next question. Question 3, it says a plane mirror on a vertical wall forms an image of an object placed in front of it. Which characteristics describe the image? So remember the plane mirror, the image we see is a virtual image. It's an upright image and it is equal in the size of the object. So these are, no, sorry, a plane mirror on the vertical forms an image of object placed in front of it. So the image that will be formed by a plane mirror will be virtual, yes, will be upright, yes, and will be in the same size and object, yes. So just consider yourself standing in front of a mirror and see how it looks like. So what exactly you are seeing is not you yourself. So you, that is a virtual image, and that is an upright image. So if you are standing, your eyes are at the same location as your eyes, your hands are at the same location as your hands, and your feet are in the same location as your feet. So it means that you're an upright image. And the person you are looking inside in a mirror, it's always on the same size as it appears to be. So the best part is it's a virtual image, it's an upright image, and it has the same size as the object. So answer D gives us the best. So no, it's not a real image. It's not a real image. Virtual image, yes. Upright, smaller, no, it's not smaller in the size. The answer D is the best part. Next question. Question 24. Which statement about light passing from air to glass is correct? So remember, air is a rare medium and glass is the denser medium. So just imagine a light ray passing through a glass prism. What happens? So this is air, this is glass. So what happens to the ray of light? So remember, we have this formula C equals to F lambda. C is the speed of light, F is the frequency of light, and lambda is the wavelength of light. So remember, when a light enters from rarer to denser medium or from denser to rarer medium, the wavelength of the light changes, and that is precisely what happens in a rainbow, that we see the constituents of white light, and we know that white light is composed of 400 nanometers to 700 nanometers approximately, or that is the wavelength of these the white light, or the white light band. So it basically changes the frequency, wavelength. And what happens to the wavelength? So the wavelength, we are coming from a denser to rarer medium, the wavelength uh, basically changes. And overall, we know that so it's a rare medium, it's a dense medium, it takes more time to travel through the glass as compared to air. So we can say that the overall uh, speed of light decreases. So frequency of the light decreases, wavelength of the light increases, uh, uh, wavelength of the light remains unchanged. Best part is basically we have to see it as a product of frequency and wavelength. So if in case it goes to this direction, our maybe our uh, wavelength will be decreasing, but our frequency will be increasing. So we basically, we don't know. It depends also on the material of the whatever the denser medium is. So generally it's better to say that the speed of the light decreases as it goes from rarer to denser medium. So next question, question number 25. Applications uh, use different components of electromagnetic spectrum, which shows correct expression of X-rays, ultraviolet rays, and microwaves. X-rays used in mobile phones, no. Ultraviolet rays, microwaves, uh, yes. Intruder alarms, microwaves, generally they are not used. X-rays killing cancerous cells. Yes, this is a use. UV light, sterilizing surgical equipments. Yes. Microwave, satellite communications. Yes. Microwaves also used for sunbed, detecting cracks in metal. Yes. Ultraviolet television controller. Generally, these are IR, infrared. Television controllers are generally infrared. So no, UV light is not generally used for this purpose. Generally in a human environment, or in a environment where we have humans interaction, UV light is rarely used in that, because it has harmful effect for the eyes. X-rays used for medical imaging, yes. Sterilizing equation, no. So the best part looks as B. Next question. Oh, sorry. 26. Where does sound travel fastest? So sound travel fastest in solids. Sound doesn't travel in vacuum. travel slowest in gases, a little more with speed in liquids, and fastest in solids. So answer is D. Next part. Question 27. It says a scientific research boat uses pulse ultrasound to detect fish underneath it. The pulse ultrasound is bound from a group of fish 600 meters below the boat. The next pulse is sent out 2 seconds after the echo from the previous pulse has been received. The speed of ultrasound in water is 1500 meters per second. What is the interval between the two pulses? So say for example, this is our boat, and somebody is standing here with a gun. So we have a group of fish here. So the pulse goes down, strikes, comes up, and is detected. So distance is, this is 6,000 meters. So the overall total time by pulse will be distance travel. Distance travel is 2 into 6,000. So that goes down and then comes up. The total distance is 2,000 and divided by the speed, and the speed is 1,500 meters per second. So the time we get is this and this is 8 seconds. Yes. So overall, so what is the total interval between the pulse? So at this t, we got pulse number 1. So it took the echo received after 8 seconds. We got echo here, and after further 2 seconds, we send the pulse 2. So the total time interval between the two pulses is 8 plus 2, 10 seconds. Answer number D is the right choice. Next question, question number 28. Which row correctly describes ultrasound? Ultrasound, again, sound waves are longitudinal waves. Sound waves are not electromagnetic waves, so sound waves are longitudinal waves. And ultrasound, remember, the human ear can hear between 20 hertz and 20 kilohertz. This is the human audible sound, and ultrasound means above 20 kilohertz, so greater than 20 kilohertz. So answer B is the right answer. Next question, question number 29. What is stored in a battery, and what is the unit? So battery basically stores energy, and uh, the units of energy are joules. So the best answer is C. Okay, so do not confuse it with ampere hours or ampere seconds or current. That is not a unit of current, amperes hour as well. So next part, next question, question 30 says a car battery delivers 150 kilocoulombs to a circuit before it needs charging. Two headlight lamps connected in parallel to the battery are switched on. There is a current of 4 ampere in each headlamp. How much time passes before the battery needs recharging? So the circuit would look something like this. So this is the battery. We have two lamps both connected in parallel. So we connect both lamps in parallel. One lamp, each lamp is having 4 amperes, 4 amperes here, 4 amperes here. So that means that total current that is going is 4 here is 8. And total charge that is provided by the battery is kilocoulomb. So the time before it needs charging, so remember Q equals to I into T. Charge is 150 kilocoulomb divided by 8 amperes is time, and this time is in seconds. So 150 into 10 to power 3 divided by 8. This is time in seconds. And remember, 60 seconds, 1 minute, and 60 minutes, 1 hour. So seconds to hour, 60 multiplied by 60. So you can, if time in hours you have to calculate, so 15 into 10 to power 3 8 multiplied by 60 multiplied by 60. So overall, we will be getting something around 5.208. So 5.208 hours. So this part D will be the best choice we have. Next question, question number 3. It says 3 identical lamps and 3 ammeters are connected as shown. The reading on ammeters are I1, I2, and I3. Ammeter I1, it measures the current that is going through this. I3, it measures the current that is going into this. What are the reading, how these readings are related? So basically, I1 measures the current through this lamp. So this is say lamp L1, this is lamp L2, this is lamp L3. So, and I1 is the total current. So I1 will be equal to I2 plus I3. So we can easily say that I1 is the largest of both of these two, right? Then we have two lamps in series and we have one lamp in series. So if we have two lamps in series, we have one lamp in series. So what exactly will be happening? So if this lamp will have a resistance R, all of these lamps will have a resistance R. So we have an effective resistance of 2R in this branch, effective resistance of R in this branch. So more current flows through a branch that have less resistance. So I2 will be larger compared to I3. So I2 will be larger than I3 and I1 is greater than both I2 and I3 because it is the sum of both. So eventually we get I1 greater than I2 greater than I3. Something like this will be the best choice. A, no. I2 greater than, no. This part C, no. I1, I2, I3. This part D will be the best choice. Question number 32. A thermistor and a light dependent resistor are connected in series. The potential difference of 6 volt is applied across them as shown. The thermistor has a resistance of 6000 ohms in cold room. So we have a cold room and we have a warm room. So this is thermistor. Thermistor has cold room 6000 and we have warm room 1000. Then we have a light dependent resistor. It has 2000 ohm. I call it as this, and it is dim light. Dim light we have 2000, and in bright light we have 500 ohms. So these are the values of resistance for thermistor and the LDR we have. Okay, so this is dim light. It's dim light, bright light, cold room, warm room. Okay, so when is the potential difference across LDR equal to 2 volts? So we have to select a combination of these rooms, or in a way combination of these resistances, in order to determine which exactly is the room or which exactly our position is, and see and we have the output voltage that is 2 volt that is appearing across an LDR, that is 2 volt. So let's try to first see the mathematics of this and see how it goes. So we have voltage across LDR. So VL is LDR equals to 2 volts, and this can be calculated as, say, resistance of LDR divided by resistance of thermistor plus resistance of LDR multiplied by the overall voltage, that is 6. We are using a voltage divider rule. Remember, this is voltage divider rule because of the series connection we have. Because of the series connection, we can use the voltage divider rule. So we can easily see that the voltage is 2 divided by 6 R resistance of LDR divided by resistance of thermistor plus resistance of LDR. So this is 1 by 3. So we can say that RT plus RL equals to 3 times RL. So my RT will be equal to twice the resistance of LDR. Okay, so just put both values of LDR here and see which corresponds to the value we have for the thermistor. So for 500, 2 into 500, we have RT as 1000. So do we have 1000? Yes. So this can be a possibility. The case 1, then case 2 is put 2000. So we have 2 multiplied by 2000. So it will be 4000. So is there is a 4000 case? So no. So this is not the case. So we can't have 2000 nim light. So the best answer is, it means that the LDR must have a 500 ohm resistance and effective thermistor will have 1000 ohm resistor, and these both correspond to the type of thermistors and LDR we are given. So we can easily say that the circuit is placed in a bright room with, oh sorry, it is bright light. So we are bright light in a warm room. So in a warm room with a bright light, answer C will be the best choice. Next question, question 33. Question 33 says that a 240 volt main circuit contains 8 60-volt or 60-watt lamps connected in parallel. At the time when the lamps are switched on, the filaments are cold and the current is 4 times as large as the steady state current in the circuit. What is the initial current supplied by the mains? Okay, so it says that it has something like this. So 240 volt mains contain 8 60-watt. So we have 8 lamps. Power of each lamp is 60 watts in parallel. At the time when the lamps are switched on, the filaments are cold and the current is 4 times as large as the final steady state current. Okay, so initially we can say that we have 8 lamps, lamp 1, lamp 2, and lamp 3 in parallel to a voltage source V, and that is 240 volts. Power is 60 watts. This is lamp 1, this is lamp 2, this is lamp 8. This is the total current that is supplied. So power is 60 watts. So we know that P equals to VI. So I lamp will be power 60 divided by 240. This is the current through one lamp, or then we have 8 of these lamps together. So we have the total current will be this I total, and this will be our steady state value. So this will be 60, 24 to 8. This will be 2 amperes. And at the time when the lamps are switched on, the filaments are cold and the current is 4 times as large as steady state. Steady state value is 4. So I initial is 4 times 2 amperes, that is 8 amperes. So the answer will be 8 amperes. That is what is our. So next question, question number 34. It says, what is used with a magnet to create an induced electromotive force in a simple AC generator? So we have a simple AC generator and we have a magnet, and to create an electromotive force in a simple AC generator. So say for example, this is our magnet. So this is the piece of magnet we have. Uh, so this is north, this is south. So AC generator. So we have a coil that is uh, allowed to move inside this. What is so our output we are taking at output is AC voltage. Okay, so our output is an AC voltage that is collected at this. So technically we do not have, we need a battery. Then do we need a coil of wire? Yes, we need a coil that is, or a coil of wire, or a multiple coils wound together for wires. So yes, a voltmeter. So voltmeter basically measures the voltage. We exactly do not need to uh, uh, need a voltmeter to induce this. Again, we do, the relay is not important here. So the best part is answer number B. So next question. It says what changes kinetic energy into electrical energy? So uh, kinetic energy into electrical energy, a car battery, no. So car battery changes like chemical energy into electrical energy. Electric fire, heat, energy, or electrical energy is converted to heat energy here. So electric motor, so motor electrical energy is converted into mechanical energy here. So no wind turbine, so wind speed is converted to electricity. So electrical energy is output, input is speed of the wind, and speed is dependent on the kinetic energy of the wind actually. So or basically speed or wind itself is the, it's a moving wind, it's a kinetic thing. So answer number D is the best choice we have. Next question. It says a transformer with 4,800 turns on its primary and 480 turns on its secondary coil. The primary coil is connected to uh, a 240 volts AC supply. Secondary connect is connected to a lamp. How does the output current of the lamp compare to the input current? So let's see how it looks like. So this is how a transformer will look like. So this is N primary, this is N secondary, this is AC circuit here. So this is 240 volts. This is my lamp. So N P is 800 tons. NS is 480 tons. Now, how does output current I in the lamp compare to the input current? Higher frequency of AC. So in transformer, the say if F input, that will again will be the F at the output. In a simple transformer, so the frequency won't be having any, there is no up and low frequency at the output side, so it will remain same. Though current in one direction only, no. So basically this is a sinusoidal current, so current will be changing its direction. So no, it's the same frequency as AC. Yes, so answer part D is the best choice we have. So next question, question number 37. It says a cathode ray oscilloscope with Y gain set at 2 volts per division. So basically this is the Y axis and gain will be measured across this. So now which row describes the signal generator and its amplitude? So signal from this waveform, we can easily say that this is an AC signal, and the Y is set 2 volts per division. So along the Y it has 2 and a half of 1 division and a half. So 1.5 divisions, and on the upside, and so from the, you can say, base or if this is the AC signal, this is the base of it. So we have the amplitude. Amplitude is from the rest position to this, or the peak. So this is 1.5 deviants multiplied by 2. We get 3 volts and as amplitude, and we have an AC signal. So answer number A will be the best choice. Some people will go with 2 divisions to half and half, so 3 divisions multiplied by 2 as 6 volt. So 6 volt is peak to peak amplitude, peak to peak amplitude, and this is not the amplitude. Generally the definition of amplitude is from this value is basically the amplitude, or normally that is taken as amplitude or the peak value for the signal. Uh, in case you are asked to find peak to peak value, then then part B will be the best answer for this. So next question, question number 38. It says potential divider uses a power supply of 12 volt. The resistors X and Y initially have equal resistances. The X resistance is half. So for example, this is R and this is R by 2. Okay, so initially if both, so initially if this is R, so the voltage across output will be, the voltage will be equally divided. So this X resistance will have 6 volt, this will have 6 volt. Now this value is R by 2. For R by 2, voltage will be, let's calculate it. So my total resistance R total will be R plus R by 2. This thing will become 3R by 2. This is my total resistance. So output voltage, V out will be R by 2 divided by 3R by 2 multiplied by 12. R by 2 cancels, so this becomes 4. So output is now 4 volts. So the output has changed by, decreased by minus 2 volts. The output has changed by part number B. No, what is the change in output voltage across X? Let's say resistance is X. Sorry, my bad. So resistance, this is across X. This 4 volt will be appearing across X. So this is this R remains same. So this R remains same. This R basically is halved. So the 4 volts is coming here. Initially 6 volts were there. So output voltage. So output voltage, if 4 is going there, output voltage will be, initially it will be 6. Now it will be 8 or 12 minus 4, 8 volts. 8 volts output will be appearing here. Again, if we have to calculate, using the voltage divider rule, so initially we output initial case R, total resistance was R plus R multiplied by 12. So we get R divided by 2R multiplied by 12, 6 volts. So we output initial 6 volts. Then second case, after it remains R, X resistance is R by 2. So my V output final case R divided by R plus R by 2 multiplied by 12. So this is R divided by 3R by 2 multiplied by 12. So this becomes 12 multiplied by 2 divided by 3. This is 8 volts. So we output final is 8 volts. Initial is 6 volts. So my output changes by 2 volts. So answer number C is the right answer. So do not make the mistake which I have made it here. So next question. Question number 39. It says, what is the definition of half-life of a radioactive element? Part A, it says half of the time it takes for one atom to decay, half of the time taken for all the atoms in a sample to decay, the time taken for half of the atoms in a sample to decay. So half of the atoms in the sample to decay looks the better answer. Uh, the time taken for a nucleon number to half. No, so the part C is the most relevant answer. In this case, we can have answer number C. Next question. Which row shows the atomic structure of a neutral atom with a nucleon number of 9? So nucleon number is 9. So nucleon number, so we have number of electrons is always equal to number of protons. So this is one thing we have to remember. So in this case, we do not have electrons and protons equal, so this will not be the answer. In this case, we have electrons and protons equal. This can be a good choice. In this case, we have electrons and protons not equal. In this case, electrons and protons are not equal. So only the best choice is the uh, part B, because for any atom, the number of protons are equal to number of electrons. So the best answer is part B. So here, so this is the last questions for our this exam. I hope I was able to you know you will be you will have enjoyed this uh, session, and I was able to make you understand some of the questions. And if you feel any issues or if you need any clarifications, please do send a message. And I wish you all the best for your exams and future endeavors. Thank you for listening.